the Beyond the Basics for Transportation. And what we'll be going over today is the difference between what we term the Essentials courses and the Beyond the Basic training guides. We will be looking at the topics that we cover in this course, Civil 3D Beyond the Basics for Transportation. And then we'll be looking at a demonstration of some exercises within this course. And in this case, it's for creating a cul-de-sac. And then we'll wrap things up and we'll spend some time with question and answers. And the whole thing should last maybe half an hour or so, depending on how many questions there are. Okay, so let's get into it. So back in 2022, ASCENT had what we termed the Civil 3D Fundamentals course. And it was a 4-day course. It was jam-packed full, and more of topics went into the appendix, so that to really cover everything, it was basically would take 5 days. And many of the topics in the fundamentals course were really advanced, so they were kind of beyond the basics. So last year for 2023, we broke the course up into 2 courses. One, which was the Civil 3D Essentials class for 3 days, and that was geared towards novices of Civil 3D. And then we took the rest of the topics covered in the original fundamentals course and put them into a Beyond the Basics for General Design, which was a 2-day course. And that was geared more towards more advanced users of Civil 3D. An important note there is that the Civil 3D Essentials course was not a prerequisite. That means that, if people are relatively comfortable with Civil 3D, they don't need to sit through and learn all the essentials, which they're reasonably comfortable with. So they can dive right into these Beyond the Basic type courses. So within the Essentials course, we covered a lot of things at a basic level, and you'll note that many of these things are actually covered in the new course that we have. For example, alignments, profiles, corridors. But these were covered at a very basic level. And what we're going to be looking at is transportation for Beyond the Basics. And this is the new course that we've introduced. And so there's advanced topics for creating transportation corridors using Civil 3D. And this is this new course, Civil 3D 2024, Beyond the Basics for Transportation. So the topics covered in this course, as I said earlier, again, it looks at alignments, profiles, assemblies, and corridors, but these are all beyond the basic levels. So we don't go through everything creating alignments. We assume that people know how to create alignments. So we look at advanced topics for the alignments. For example, offset alignments and best fit profiles, reversing alignments, creating profiles for the cul-de-sac, various ways of creating advanced or beyond the basic assemblies, for conditional assemblies, for sidewalks, creating widenings within the corridor, different ways of doing that. We look at creating intersections, using the intersection wizard, which we do cover in the essentials, but again, we dig a bit deeper, and this one will be a 4-way intersection where we include widenings. We look at creating intersections manually by creating the alignments for a couple quadrants, and using feature lines for the other two quadrants for the four-way intersection. We look at creating roundabouts and cul-de-sacs, and this will be the exercise that I'll be going over. And then we wrap the whole course up with corridor adjustments, which is basically kind of a hit list of things that you can do with corridors, where we can extend a corridor, where we can add widenings to a corridor without using an alignment. Super elevations. Now, these are more or less residential, urban, rural type roads. So super elevations aren't critical for this because the speeds are not that high. And the super elevation exercises, well, they're a little bit lame because the speeds are so slow. But still, we cover the topics. We look at how super elevations are created, look how we can control that with the design criteria, and then rehab corridors, where we take an existing corridor and it needs to be rehabilitated. So we look at the milling and the overlays. We create various assemblies for the specific criteria for the rehab, for the new corridor, and then we generate quantities for that. So all in all, there's a lot going on in this course. It's close to 400 pages, and the course is geared to be a 2-day course. So the exercises that I will demonstrate is how to create a cul-de-sac. And we basically start with an alignment from a curb line. And then we generate profiles for this cul-de-sac. And then we look at how to create assemblies for that. Now, in this case, as I said, this is beyond the basics. So the alignment for the curb line is actually already provided. Because as I said, it's already 400 pages, and I don't want to go back to the essentials of creating alignment. We can assume that you know how to create an alignment or basic alignment for this. So this alignment is already given, and then we look at particulars for creating a profile for that alignment for the cul-de-sac. And we go through and generate an assembly for that. And then finally, we spend quite a lot of time looking at the specifics for creating this cul-de-sac by adding a baseline to the corridor, adding a region within that, applying the assembly to that, applying the targeting for that assembly, and then fine-tuning the corridor by adjusting the regions with the grips. The whole workflow is very similar to creating a cul-de-sac, a knuckle, I'm sorry, for the curve. And I'll be going over and doing that on showing how we create this knuckle. And then finally, this is the final product where we have a nice corridor coming up with the knuckle and the cul-de-sac. So one thing with this course is, for example, if I go to open, those that have used our courses in the past will recognize this particular data structure where we have configuration files, we have plans, documentation, and most of the drawings reside in the working folder. And the working folder is comprised of one per chapter, basically. So we have one for alignments, assemblies, corridor adjustments, etc. And within all of these, it's basically, we start with a particular drawing, and then you can go through each exercise and within the chapter, And you can basically follow the whole exercise with this original drawing. Or if you get stuck or if you don't feel quite comfortable, then we have a variety of drawings so that you can either continue on with the previous drawing, or you can open up the next drawing where everything is done for you and you can continue on for that particular exercise. And normally in the end, we have a completed drawing so that you can actually open that up and see how everything is done. That's quite typical of our courses, that we offer, the first drawing, various stages of the drawings, and then the completed drawing. But what I have here in this webinar obviously is not part of your data set. But in that I have my webinar drawing. And I typically work with a white background, primarily because I'm creating all these screen captures for the courses, and it looks much better with a white background. Okay, so let me hook. Okay, so another thing that we do quite often in the book is we use these views quite extensively. We have all these different views. So it's a lot easier. We just say, go to this particular view, and it zooms into the area that we want to work on. So it makes it a lot easier to tell you where to go in the drawing, rather than telling you to zoom and pan to this particular region. And so, for example, here for this, we have this alignment already made for the ASCENT cul-de-sac, as well as this alignment for the knuckle. As I said earlier, we're not going to go through and tell you how to create all the alignments, but we look at various tools for advanced beyond the basic tools for creating alignments. So what we want to do is, you see that we do have our curb return alignments for the ASCENT cul-de-sac, but we don't have any profiles yet. You can see that in my prospector here. So the first step is we want to create these profiles. I select my alignment, the cul-de-sac, and I'll explain why I'm doing this when we generate the profile, but I want to select the ASCENT top and the existing site and create two profiles for these. Now, when we create a profile, basically what we do is we plot the profile as where the alignment runs. In this case, how it runs across the existing surface, as well as how it runs on the ASCENT top surface. And just to be able to distinguish them, I'm going to select my ASCENT top and give that a different style. Once again, we don't go through every part of the create profile view dialog box, because that's covered extensively in the Essentials class. So we simply select the profile, create the profile, and place it down here. So what we want to do is, for the cul-de-sac, essentially what we do is we attach the assembly that we'll be creating next onto this perimeter. And that assembly is going to target, the lane is going to be targeting inside, and it's going to be targeting this alignment. So what we need to do is we need to generate a profile to show how this how these assemblies are going to be attached onto this alignment in elevation. And that's why we needed to generate the existing ground as well as the ASCENT top surface, because we want that profile to tie in to this, for the ASCENT top, this is the end of the curve. So that's how we want the corridor to tie into that. So I'm going to generate a, open up my profile creation tools, select my profile view. I'm going to call it alignment, the alignment name -DGN. Keep everything the way it is. Again, we don't go through all the details like we did in the Essentials class. I'm going to simply create a line, a fixed tangent, between this endpoint and this endpoint, which represent the curve elevations for ASCENT place. Now I want to create a insert a PVI at the midpoint for drainage purposes. Then I want to provide a slope onto this, and I can decide if it's going to slope up or slope down, based if that's going to be a drainage point or a. So in this case, I'm going to slope it up, giving it a 2% grade out. And as I do that, then you'll see that it grades out at 2% and then comes back down at -2%. So then this is a drainage point, not a catchment area. Be the high point. Now I could leave it like that, but let's just add a vertical curve, parabola-based, PVI-based. And I select near my PVI, and I'm going to have it set to 150 feet. Now, one trick with Civil 3D is you notice that the labels haven't updated because Civil 3D wants to add another curve. So I have to hit enter again. And now Civil 3D updates. It's not update the way it should. So the last thing we want to do is we just want to take this label. It's beyond the profile view, just drag it down. Okay. So we have our alignments, we have our profile. Now let's look at the assemblies. Again, we don't go through every detail of creating assemblies. Just briefly create an assembly for us. Let's go here. Two. Okay, so a lot of the assemblies are already here. So just to show you how to generate an assembly quite quickly. I'll just call it test. And I like to refer to assemblies as building with Lego blocks. This is my assembly. These are all the sub-assemblies that we have. And this is all written up in the book. Let me just make sure that I'm. Well, so I want to put in a lane super elevation, axis on rotation. And the book goes step by step as to what these various figures are. 14.75. And my slope is 2%. And then I pick my assembly and it puts it in. I go to my curbs, general curb. That side is going to be the left, now the right. And there's one variable I need to change. Dimension B is going to be 24 inches. And I pick the assembly again, and it puts it on the right. Then finally, I go to my length, slope, width, and slope. It's on the left, it's on the right side. The length is 7.193. I put this at the here. Okay. Just going to save the drawing. So the this is the attachment point of the assembly. It goes around the perimeter of the cul-de-sac. This lane is going to shrink and expand to meet the ASCENT place, the center line, which is the ASCENT place alignment, as well as the ASCENT place design profile. And then this link is just going to radiate around the cul-de-sac. So let's go generate the cul-de-sac now. And I want to generate a cul-de-sac, I need to add a new baseline to it. Because if I look at the corridor properties of ASCENT place, currently it has one baseline with two regions before the intersection and region start. And if I highlight that baseline, it highlights in the drawing. So we need to generate another baseline and another region to attach this assembly to. So with my corridor highlighted, I go to add baseline. Just call it cul-de-sac. And the alignment is my ASCENT cul-de-sac that was generated in a previous drawing. And this is my design profile that I just generated. You see I have my existing surface or the design profile that I just generated. Okay, so now we have a new baseline. Now we need to add a region to that baseline. So I add a region. It's asking me for the baseline, and you see that the various ones get highlighted. And I want to go, type F for fill so that the entire alignment baseline is filled for this region. And again, I'll call it, I'm just going to call it bulb. And my assembly for that is that assembly that we just generated, test. Well, in the book, actually, it's residential curb return left, but I'll use test. Okay, now, so we have the assembly attached here. Now we need to tell it how it's going to target it. So for my width target for the, for my lane super elevation, my width target is going to be my ASCENT place alignment. And for the elevations and targets, it's going to be my ASCENT place design profile. Okay, so it comes in, it's a little bit choppy because we need to adjust the frequency. So I select the region and I go to edit frequency for this particular region. I'm going to make it 5 feet along the curve. And we're going to also set the mid-ordinate distance for 0.15. And then we would just adjust the corridor with these grips. Oops, already done, to make sure that the regions don't overlap. And very quickly, I'll do the knuckle, show how that's done. It's actually a little bit simpler. I'm going to split my region. Point of this alignment at this region to the end point. This alignment. Then I can go to my corridor properties. So here you see the baseline for the cul-de-sac. And these regions, we can rename them. But for the running a little bit out of time here, I'm just going to rename one. I'm quite a stickler for giving Civil 3D objects good names so they're recognizable. So this region is the knuckle region. I just renamed it to knuckle. I'm going to set my frequency for the knuckle region. Target, that was the target for the knuckle region. And it is on the left side of my width target, super elevation axis of rotation left. It's on the left side. And my target is going to be my ASCENT knuckle that was generated in a previous, that was given to us already. And then let's set our frequency for that, 5 feet. So this is typical, you know, we do, for the exercises, we show multiple ways of doing it. Some cases we use feature lines for targeting, other times alignments. And that's fine. Let me save the drawing. Then we have our completed corridor with the bulb and the cul-de-sac and the knuckle. Okay, let's head back to our presentation here. So to recap, we looked at the this newest offering by ASCENT for Beyond the Basics. This one is for transportation. We have one for general design, and we have one for grading. For this transportation, we looked at alignments, profiles, and assemblies. We build corridors. We generate intersections, roundabouts, and cul-de-sacs, as you just saw. We get into some software corridor adjustments. We apply super elevations, and we generate a rehab corridor. And then we looked at a demonstration how to create that cul-de-sac bed.